Today we are going to discuss some numerical questions, okay, from structure of an atom. So first one is calculate the energy associated with the first orbit of helium. What is the radius for this orbit? Okay, question Amriera. Okay, so calculate the energy associated with first orbit of He plus. So you need to calculate E1, okay, for He plus. Now for hydrogen-like species, this is not hydrogen, but for hydrogen-like species, so hydrogen-like species means which contain one single electron, hydrogen को मान एउटा इलेक्ट्रोन हुन्छ, helium मा पनि एउटा इलेक्ट्रोन छ. So energy को formula छ En is equal to, okay, minus 2.18, okay, into 10 to the power minus 18 Z square by N square, and you will get answer in Joule. Okay, sir. Now here for Prasanna mute rakhala. Prasanna mute rakha. For your helium. Helium ko lagi Z is equal to 2. Okay. And N here is N is equal to 1. This is 1. N equal to 1 ma calculate गर्नुपर्छ. So now E1. E1 huncha is equal to minus 2.18 into 10 to the power minus 18, okay, into Z कति छ हाम्रो helium. For helium is 2, so 2 square divided by 1, हैन, 1 square. So you will get is minus 2.18 into 10 to the power minus 18 into 4, okay, and multiply this by 4. कति आउँछ तिम्रो minus 4 8 जा 2 हातमा रह्यो 3 7.8. So you will get is 8.72 into 10 to the power minus 18 joule as answer. By minus 8.172 into 10 to the power minus 18 joule is energy associated with first orbit of helium. मैले यो भिडियोमा पनि गरिदिएको छु. Again I am doing it. Now next question, बुझ्यो यो? Hope you have understood. Now next is question, read gara. What is the question? Okay, electron of hydrogen atom from first Bohr orbit. So Ni 1 देखि shift गर्नु पर्यो to fifth orbit. Nf छ तिम्रो 5, final is 5, okay, and energy निकाल्नु पर्यो यो transition को लागि how much energy is needed. So del E you need to find out. Ni is given to you, Nf is Ni 1 to 5 मा jump गर्दा energy कति चाहिन्छ, okay, and you are also asked to calculate lambda wavelength, okay, wavelength of light emitted when your electrons return to the ground state. तिम्रो 1 लेभल देखि जस्तै this is 1 2 3 4 5 है, यहाँदेखि 1 देखि 5 मा जम्प गर्यो. So त्यति बेला तिम्रो एनर्जी कति चाहिन्छ. So that you are asked to calculate daily कति चाहिन्छ. र again तिम्रो 5 देखि 1 मा जम्प गर्दा energy will emit, and यो जस्तै रेडिएसन को ल्याम्डा कति छ you are asked to calculate. बुझ्यो हैन? del E चाहिएको छ and you are asked to calculate lambda. Okay, now suppose your electron is like there, if the transition is taking place, so कुन चाहिँ formula you are going to use is del E equal to, okay, 2.18 into 10 to the power minus 11 दिएको छ हैन. So minus 11 अर्थ मै छ. So तिम्रो 11 लाई जस्तै 1 erg is equal to okay 11, so 11 into minus 10 to the power minus 7 गर्दाखेरि you will get is minus 18 नै पाउँछौ. Okay, because 1 erg छ, so you have E1 दिएको छ तिमीलाई 2.18 into 10 to the power कति छ minus 11 erg छ, so erg लाई joule मा convert गर्दा you will get is 2.18 into 10 to the power minus 18 नै पाउँछ. ठिकै छ, so 18 आउँछ. Then 1 by ni square minus 1 by nf square. So initial र final. Okay, so तिमीहरूको यो भयो. So E1, so E1 is like तिमीहरूको ground state को बताइदिएको छ 2.18 into 10 to the power minus 11 erg, and when you convert erg to joule भयो, so 10 to the power minus 7 or 10 to the power minus or 10 to the power minus 11 गर्दा you will get is 10 to the power minus 18, and formula for del is 2.18 into 10 to the power minus 18 1 by ni square minus 1 by nf square. ठीक है यहाँ सम्म ni and nf we have 1 and 5 भयो, so value substitute गरेको, so 2.18 into 10 to the power minus 18, then 1 and I कति छ, I is your 1 by 1 is 1 only, minus f is nf कति छ 5 छ, so 1 divided by 25 हुन्छ. ठिकै छ, so again this you can write as 2.18 into 10 to the power minus 18 भयो. अन्त यो कति हो 25 माथि जान्छ, 25 minus 1 गर्दा 24, you will get this as 24 divided by 25 भयो, 24 divided by 25 बुझ्यो होला. Very simple चाहिँ. So तिम्रो del E पायो, del E is equal to 2.18 into 10 to the power minus 18 into 24 divided by 25. Okay, now when you do the multiplication division answer कति आउँछ, so you need to 2.18 into 24 divided by 25 गर्दाखेरि you will get answer as 2.0928. Okay, into 10 to the power minus 18 joule. Okay, so you पायो तिमीले energy. This is your energy 10 to the power 18 joule ma. Now next is what you are asked to calculate. Daily ATI. Now you are asked to calculate lambda. So lambda is equal to how much? Okay. Now timala formula yaad cha. So del E is equal to h nu, and h nu is equal to hc by lambda. ये formula लगाउँदा भयो. So therefore तिम्रो lambda हुन्छ. Okay. So your lambda is कति हुन्छ न त hc by del E. ठिकै छ. So now what is h? H is Planck's constant. Your value याद भइसक्यो होला तिमीलाई 6.63 into 10 to the power minus 34. Okay, into c. C को value कति हो याद छ? 3 into 10 to the power 8 याद राख्नु पर्यो. Divided by del E हाम्रो कति आएको छ 2.09 गर्दा भयो into 10 to the power minus 18. So again you do the multiplication division. So Planck constant को value अरु याद हुनु पर्यो तिमीहरुको. C को value is your 3 into 10 to the power 8 यो याद राख्नु है. 3 divided by 2.09. So if you divide multiply digit only, यो मात्रै digit हरुलाई मात्रै multiply divide गर्दा you get this 9.51 into भयो. And you have like यो कति हो 34 छ, यो माथि जाँदाखेरि 26 हुन्छ. 18 हेरे 8 छ, यो माथि जान्छ 8 plus 18 हुन्छ. कति हुन्छ 8 plus 18 is your 26. So 34 minus 26 गर्दाखेरि you will get is 8. So you into 10 to the power minus 8 आउँछ, and यसको value केमा unit के हुन्छ. So तिम्रो यो जुन चाहिँ c को value छ it is meter per second. So यो value तिम्रो मिटरमा पाउँछौ. So your lambda okay, is 9.51 into 10 to the power minus 8 meter, and E is equal to 2.0928 into 10 to the power 18. Kokosle bujo, kokole bujena, let me know. Look, bye. Now, timro radius ko what is the formula? Mandakeri radius, okay, for hydrogen-like species. Radius for hydrogen-like species is for hydrogen ko dinchu is equal to 0.529 into n square. Okay, you for hydrogen. For hydrogen like species. So hydrogen like species ma तिम्रो helium आउँछ, lithium आउँछ, त्यो याद राख्नु. Okay, 0. यो चाहिँ angstrom मा हुन्छ है. It is in angstrom. Okay, 0.529, okay, and square हुन्छ तर divided by z हुन्छ. Now what is z भन्दा z is atomic number. Z is atomic number र n भनेको first हो कि second हो कि third हो ल. So number 1 मा सोधेको छ third orbit, okay, of He plus. Okay, for third orbit of He plus यहाँ तिम्रो n छ 3 र z helium हो. Helium को atomic number is 2. ठिकै छ. So R3 of He plus हुन्छ तिम्रो कति हो 0.529 into n square 3 square divided by z. Z is 2. ठिकै छ. So answer कति हुन्छ 0.592 into 9, okay, divided by 2. So 0.59 5 into कति छ 9 divided by कति गर्नु पर्यो 2 गर्नु पर्यो. So answer आउँछ तिमीहरुको 2.38 angstrom मै आउँछ है. Angstrom मा थियो, angstrom मा you will get the answer. ठिकै छ. Then number 2 मा सोध्दैछ तिमीलाई, यो तिमीहरु गर ल, म लेखिदिन्छु मात्रै. So second खाता किताब सबै यो राखिराख of Li plus 2. Okay, now second भनेपछि n तिम्रो 2 हुन्छ र तिम्रो z lithium भनेपछि it is your 3. So तिम्रो R2 निकाल्नु पर्यो of Li plus 2 okay, र formula is 0.529 into तिम्रो n square. N is 2, so 2 square divided by your z. Z is 3. कति हुन्छ भन त मलाई answer. हेरे question हेर्दै गर. What is the wavelength of light emitted when the electron in hydrogen atom, okay, undergo transition from an energy level n equal to 4 to n equal to 3. अब यता नि again transition is taking place where you are asked to calculate wavelength. अघिकै जस्तै हो. Now what is Ni here? Ni is 4, okay, and Nf 4 देखि 2 मा. So Nf is 2 and you are asked to calculate lambda. Now for lambda you need is energy del E निकाल्नु पर्यो. So del E is equal to how much? अघिको formula याद गर. So del E is equal to minus 2.18 into 10 to the power minus 18. भयो. 1 by यो हेरे transition को लागि चाहिँ use this formula Ni square minus 1 by Nf square. ठिकै छ. Now minus 2.18 into 10 to the power minus 18. Now your Ni भनेपछि के हो 4 square minus 1 by 2 square. ठिकै छ. So तिम्रो answer आउँछ minus 2.18 into minus 2.18 into 10 to the power minus 18. Right? So 1 by 16 minus 1 by 8. गर्नु सक्छ यहाँदेखि उता तिमीहरू ट्राई गर्दै गर्दा हुन्छ सो 2.18 into 10 to the power minus 18. So you know to solve this. 1 by 16 minus 1 by 8. So you will get is 2 that's answer 1. So 1 minus 2 is minus 1. So you will get answer in you plus must say sorry. So you will get answer in minus 1 by 2. That's all. So तिम्रो del E हुन्छ del E is equal to minus plus 2.18 into 10 to the power minus 18 divided by minus 2 cha. So you will get answer in minus 0.0 sorry minus 1 point minus 1.09 into 10 to the power minus 18. So energy तिम्रो के हुन्छ release हुन्छ. So whenever it jumps from higher level to lower level, right? So your answer बुझ्यो यो minus 1.09 बुझ्यो यो ठिकै छ. Now तिम्रो के निकाल्नु भन्दैछ तिम्रो you are asked to calculate lambda. So what is lambda? So again formula use so it is equal to del E. Okay, तिमीहरु पहिला निकाल del E is equal to hc by lambda. So you will get lambda is equal to hc by del E. And h is Planck constant value कति हो 6.63 into 10 to the power minus 32. C is 3 into 10 to the power 8 divided by del E हाम्रो कति आयो magnitude मात्रै लेखिदिनु ल माइनस साइनहरु नलेख्नु magnitude मात्रै and that is 1.09 into 10 to the power minus 18. लु यसलाई डिवाइड र मल्टिप्लाई गरेर tell me the answer. लु त छिटो 16 गर त अभिषेक गुरुङ you tell me the answer. So 26 गर्दाखेरि 32 will be in minus 8 and answer will be in meter. Abhishek, what is the answer? खातामा लेख्दै गर. Abhishek, solving calculator use गर्दै अहिले त घरमा बस्दा तर manually you need to do है किनभने एक्जाममा पढ्दैन. Since अहिले fast there's no time you can use calculator. Answer is 18.24 into 10 to the power minus 8 meter. This is your answer. Kavita, बुझ्यो? Yes, ma'am. Next, what will be the wavelength of a ball of mass 0.1 kg moving with velocity? Okay, now see यता तिम्रो के छ wavelength सोधेको छ velocity सोधेको छ. So wavelength र velocity को relationship दिन्छ de Broglie's equation. Okay, so now you need to use this de Broglie equation. Now what is it? तिमीलाई बिर्स्यो होला. What is de Broglie equation? It is lambda equal to h divided by mv. यिनीहरु फर्मुलाहरु खाताको अगाडि पेज लेख पेपरमा लेख you just pasted it on wall. Okay, now here so you are asked to calculate lambda. The mass is given to you and this is 0.1 kg. Mass is 0.1 kg and velocity is given 10 meter second inverse. Okay, र h is Planck's constant तिमीलाई याद हुन्छ या दिएको हुन्छ. Now lambda कति हुन्छ then? Now so lambda equal to h 6.63 into 10 to the power minus 34 divided by mass is 0.1 into 10. Okay, so when you multiply the two, you'll get 0.1 र 10 multiply गर्दा 1 पाउँछ. So 1 पाउँदाखेरि answer हुन्छ 6.63 into 10 to the power minus 34. Okay, so this divided by 1 is 80. The answer timro meter ma. Do not forget to write down the unit. So you will get lambda equal to 6.63 into 10 to the power minus 34. Okay, so wavelength, velocity, de Broglie equation याद राख्छ. हेरे भिडियो हेर्नु पर्यो तिमीलाई याद छैन भने. Now next, an electron is moving with a kinetic energy. Right? Kinetic energy is given Ke is equal to 2.2575 into 10 to the power minus 25 joule. Now what you are asked to calculate is lambda. So kinetic energy move gardaisa, wavelength सोध्यो भने again de Broglie equation. Now what is your de Broglie equation? Lambda is equal to h by mv. So again this equation you need to use, but what is given to you? No velocity but kinetic energy. And from kinetic energy you can easily calculate velocity. कसरी? याद चला formula. What is relationship between kinetic energy and velocity? Koni? Half mv square. Okay na? हाँ? वो कि आई ना बना था? So v square is equal to 2 into kinetic energy divided by mass. Okay, and v भनेपछि root over. उता जाँदाखेरि के हुन्छ? Root over. ठीक है, so v is equal to 2 into kinetic energy divided by m. Now what is 2? What is kinetic energy? कति दिएको छ? 2.275 into 10 to the power minus 25. Okay, divided by what is m here? Mass is given. Mass of electron सधैँ same हुन्छ, दिएको छैन. याद गर्नु 9.1 into 10 to the power minus 31. So now solve गर्नु पर्यो तिमीहरूले. Okay, so कति छ? 2 into 2.275. Okay, divided by 9.1. So you will get 0.5. Root over of 0.5 and 25 र 31 माथि जान्छ. 31 माथि when it go up plus हुन्छ. So plus 31 minus 25. So you will get is 10 to the power 6. Okay. So 50 को root over of 500 into 10 to the power 4 गरिदेऊ. किनभने 10 to the power 4 even number मा छ भने जहिले पनि के हुन्छ तिम्रो this 10 to the power 4 into half हुन्छ हैन. याद छ ल यो सबै क्याल्कुलेसनहरु. So you will get is into 10 to the power 2 हुन्छ. 10 to the power 4 को root over कति हुन्छ? 10 to the power 2 हुन्छ. Now 500 को root over कति हुन्छ? So you will get is 22.36. Okay, 22.36 into 10 to the power 2 huncha. So this is your velocity and you will get in meter. Eta maile ke gareko chuna, just what I'm doing here is calculating your velocity from kinetic energy. The kinetic energy ke cha भन्दाखेरि kinetic energy is equal to half mv square. So v huncha 2 into kinetic energy divided by m. सबैको value substitute गरिदेऊ. Okay, and you will get the value of velocity. The velocity is 22.36 into 10 to the power 2. Okay, now what is the main task is to find out lambda. So lambda कति हुन्छ? Lambda is equal to h by mv. So h is 6.63 into 10 to the power minus 34 divided by m is electron move, 9.1 into 10 to the power minus 31 and velocity हाम्रो निस्केको छ 22.36 into 10 to the power 2. ठिकै छ? Again you do the calculation. So calculation गर. So calculation गर्नु पर्यो तिमीले. Okay, 6.63 divided by 9.1 divided by 22.36. So you will get 3.25 into अब यो हेरे minus 31 र 2 छ. Okay, minus हुँदाखेरि minus 31 र 2 गर्दाखेरि you will get is 29 माथि जाँदाखेरि 5 हुन्छ 10 to the power minus 7. You will get lambda as 3.25 into 10 to the power minus 7 meter. ठिकै छ? So you just calculation मात्रै गरेको छु. Multiply divide गर्नु तिमीलाई आइहाल्छ. Formula how to use I am telling you. यो बुझ्यो सबैले? Kinetic energy, first convert this to velocity, and if you get the velocity you can easily find out the value for lambda.